Hi, I'm Ryan from running Hackspace, and we're here with Stan, our newest massive laser in our growing collection of amazing laser technology. He's a 1.6 kilowatt CW YAG laser, um, and we're going to talk you through a little bit about the technology that's in him and how you can get involved with the project, where we need help, and what the plan is. Stan is a Rofin Sinar, or Rofin DY016. The 016 means 1.6 kilowatts. So when he was new and when he's fully working, he should be able to put out 1.6 kilowatts of 1064 nanometer coherent light down a pair of water-cooled fibers that come out the top. And that's the whole purpose of this machine, is to generate lots of coherent light. Up top, you've got the optics cavity, where you've got a shock-mounted beam deck with 3 pump chambers that each of them has a 500 watt capacity. Inside that chamber is a YAG rod, which is pumped with luminous flux from diode bars. You see that there's a lot of plumbing inside it, and 2 fiber launches here. So this is where the light is directed down either one of the 2 fibers, and you can have different proportions of light going down the different fibers to do different jobs. And this is the plumbing. Every optical component in this thing is water cooled. The rods, the diodes, the mirrors, the fiber launches, the fiber optic cable itself, the end effectors of the fiber, even some electrical components are water cooled. The power supplies inside here are water cooled. So basically, yeah, that's the front view of the top deck of Stan. So open up the bottom, you can see a little bit more. This is the sort of control side of life. You've got a mains inlet here, so that's where 63 amps of 3-phase comes in. There's a mains input filter which is currently bypassed in order to stop it from tripping RCDs in the space. Big disconnect, then 2 contactors, and a whole bunch of mains control equipment to drive 3 big power supplies. These power supplies run the diode bars, so they'll provide very high current DC to the bars up top. Around the side there's some more control electronics. Around that side there's a whole bunch of plumbing. So why Stan? Well, because he came up on eBay, and it's far and away the most powerful laser I've ever seen, and it's a great, interesting project and an interesting way to learn about heavy-duty, serious industrial lasers. One of the things that we say when we're talking about the big laser cutters upstairs, everybody who doesn't really know laser cutters that well, hasn't come across one before, one of the questions they often ask is, can it cut metal? Well, with this, we can stop saying no. Maybe. One day, hopefully, we'll see. So the state of play right now is we've got him, he's here. I love how it's named Stan, by the way. He's on wheels so he can move, and we've powered him up once to check what the sort of faults reported by the controller system are, and it's reporting that it's not got any water, we think. We're still trying to understand what the control electronics do in terms of what communications protocols they use and what software is on them, how we can speak to them, basically, and what we can get out of it in terms of status information. Immediate next steps are mainly infrastructure based, so getting enough water pressure into them at enough of a flow rate to get the interlocks to open so that it will move on to the next step in its startup procedure. We've got it to the first step in its startup procedure, then it just stops and you hear valves clicking over by the water supply because it's not happy that it's not got any water coming into it, we think. So to that aim, we've got a chiller. It's not a refrigerant chiller, it's just a heat exchanger, but we're hoping that it can provide enough power, enough pressure and flow to get the interlocks to open up. we've wired in 63 amps of three-phase, almost wired in 63 amps of three-phase over by the main supply, and hopefully we should be able to shove that up it, because this is the power input. After that, it's an unknown at this moment. We think that it'll probably work. We haven't seen anything that's wrong with it specifically. There's been no, there's not any major water leaks or any burnt electrical components or anything like that that would suggest there's a problem. There's one thing that's a bit strange. They've gone to a lot of effort to put in humidity sensors inside the pump chambers up on the optics deck. And those seem to be reading high humidity within the pump chambers. So we need to determine what that means, see about getting them desiccated, and if that's a problem, we need to solve it. So we're going to do some looking into that. And so yeah, that is an overview and the front of Stan.